Hello, race fans. Today we have an exciting race for you. If Shellington wins, you guys have a test next Friday. And the sixth graders just took a test, so you still have another test. If Quasi wins, you guys have a quiz on Friday. But if Captain Barnacles wins, then you guys get suckers. The next time I see you, I owe you all suckers. So let's see who's gonna win this exciting race. First, here goes Shellington. All right, now here goes Quasi. Last but not least, here comes Captain Barnacles. Oh, almost won. That's too bad. Okay, looks like you guys have a quiz. Good job.
All right, welcome back. First off, you do have a quiz on Friday, but also know I will give you suckers the next time our paths cross. Okay, so that's what's going on with that. Game plan for the week: you got a small video today, a reading tomorrow, a small video on Thursday, quiz on Friday, and then from then on out, it's Jeopardy and review. Except for next Wednesday. Next Wednesday, Mr. Evans live, 10 o'clock. Put it on your calendar. Zoom meeting. Be there if you can be there. Okay? All right, guys. Welcome back. Here we go. We're talking about science and exploration. We're going to be talking about the universe and the fact that at first people thought that the Earth was the center of the universe and how that evolved into the models that we have today. Okay, so we'll talk about the difference between Copernicus, Kepler, Galileo, Newton. We might get to Columbus today. Let's get going. All right. You should be able to link the name of the scientist with their achievement. So if I say Copernicus or I say Kepler, what's the difference? You should know that, okay? We're going to talk a little bit about the principles of modern science. You should know this stuff. How do we go from Zeus causes lightning to electrical charges cause lightning? How do we come up with the scientific method? That's what we'll be talking about. And then understand the importance of exploration. You should know some of the importance of exploration. You should remember Columbian exchange. That's right. Okay. Remember ancient Greeks? Okay. What caused lightning at the very beginning? Zeus. Remember Zeus? Okay. They used mythology to explain the world around them. All right. Now we're going to use something else to explain the world around us. We're going to use science. Okay. And so it means knowledge or understanding. Before science comes around, what is the institution that is the source for knowledge? The Catholic Church. Very good. And what event challenges the authority of the Catholic Church? We just covered this. The Protestant Reformation, all right? And what invention helps the Reformation spread throughout Europe? Exactly, the printing press. Good job. Okay, so science. I'm not going to pretend to be a science teacher. You guys know as much as I do, I'm sure. Okay, you observe something happening in the actual world. You go, You come up with your hypothesis. You use your logic. You come up with your theory. And then you develop a test. And you test your theory, an experiment. Does that make sense? Okay. So Ptolemy, Aristotle, they have a model that the Earth is at the center of the universe. And on the left there, you see it looks all simple. But then they start observing the actual trajectories of the planets and it doesn't match up. So then they have to make each little planet do a little loop-de-loop and then they have to have these rotations and then you get what's looked on at the right where that's what they're saying is how everything flows together, okay? Copernicus comes along and he says, no, that's not how it is. He says everything goes around the sun. And if you just make the sun the center of the universe, then all the math is going to make more sense and it's going to be more accurate, okay? And so that's what he is going to write this book. But he still thinks everything's a circular orbit. Then Kepler comes along and he discovers elliptical orbits, okay? So if I say, what's the difference between Copernicus and Kepler? Copernicus puts the sun at the center of the model. Kepler decides that they're not circles, the orbits are elliptical. I know I'm going fast. You can rewind it if you need to. Watch this fun video. Here we go.
You, me, every single thing on this planet, we're all zooming through space right now, orbiting the sun at an average speed of 107,000 kilometers an hour, and rotating while we're doing it. But the sun, moon, planets, and stars all look like they're moving through the sky, right? So it's easy to imagine that we're staying put while they all move around us, as long as you don't look too closely. Which is why the whole idea that the Earth orbits the sun wasn't really accepted until a few hundred years ago, and it took a lot of convincing. A lot of the old geocentric model, where Earth's at the center of everything, was based on ideas developed by ancient Greek philosophers Aristotle and Ptolemy. They explained that the Earth stayed put at the center of everything, and anything we can see in the sky, the sun, the moon, stars, planets, everything, orbited it in perfect circles. But that didn't explain why planets, which at the time referred to anything that looked different from the background stars, including the sun and the moon, sometimes changed brightness or occasionally looked like they were moving in a completely different direction. So the geocentric model tried to explain them using epicycles. These are imaginary points that were moving in imaginary circles with planets orbiting around those points. And it sort of worked, though eventually they had to draw more circles around the circles to explain some things and have the planets move faster or slower at certain points in their orbits. Diagrams of the sky were kind of a mess. There were at least a couple of Greek philosophers who disagreed, and the geocentric model was questioned by Muslim scholars since at least the 10th century. But for a long time, especially among Western civilizations, it was just accepted. Everything revolved around the Earth, even if it was hard to explain sometimes. At least until Copernicus came along. Nicolaus Copernicus was a well-known Renaissance thinker who spent the last few decades of his life developing a heliocentric model, where the sun is the center of the universe, which he published just before he died. And okay, we know that the sun isn't the center of the universe, but it was a lot closer to the truth. Copernicus realized that the math was a little simpler if you just had Mercury, Venus, Earth, Mars, Jupiter, and Saturn, the only planets we knew about at the time, orbiting the sun with the moon orbiting the Earth. He used epicycles too, but all the planets in his model kept the same speed throughout their orbits, which is what you'd expect if the orbit is a circle. But it was still hard to prove that the heliocentric model was more accurate. For one thing, even if they made things simpler, those circular orbits in Copernicus's universe were wrong, and it was just as bad as the geocentric model for predicting how the planets would move. Then in the early 1600s, Johannes Kepler realized that orbits didn't have to be circles, and if he assumed that they were ellipses, the math fit the motion of the planets, sun, and moon a lot better using the heliocentric model. Around the same time, Galileo Galilei's telescope made things even more convincing, mostly thanks to Jupiter and Venus. When Galileo pointed his telescope at Jupiter, he was able to see its 4 biggest moons: Ganymede, Callisto, Io, and Europa. They were pretty concrete proof that not everything in the sky was orbiting Earth. Then he noticed something weird about Venus. It goes through phases just like our moon does, from new to full and back, but it's much bigger when it's new than when it's full. That made no sense in the geocentric model, which predicted that sometimes Venus would be closer to Earth when it was new, but sometimes it would be closer when it was full. In the heliocentric model, though, the sun, Venus, and Earth lined up so that Venus would be closer to Earth when it was new. Even with all this evidence, it took a long time for the heliocentric model to be accepted. The church banned heliocentric works until 1758. These days we know that the heliocentric model wasn't exactly right either. The sun isn't at the center of the universe, there's a lot more out there, and if you want to get technical about it, both Earth and the sun orbit the same point, the center of mass of the solar system, which is just the center point of all the objects in it, based on their mass and how far they are from each other. Since the sun has 99.87% of all the mass in the solar system, the center of mass is pretty close to the center of the sun. But it does move around a bit, depending on where the planets are in their orbits. But one thing we know with 100% certainty is that the geocentric model is wrong.
All right, welcome back. We have Galileo. He gets the telescope out. He observes the 4 moons of Jupiter, learns about mechanics, sets up experiments. Okay, here's the thing though. Galileo is going to say some things that go against the church. What's that word? If you say something that goes against the church, heresy. Remember that? He's going to be labeled a heretic and basically banished. Okay? We'll stop there for today. We got plenty more coming up. Make sure that you are around next Wednesday for Mr. Evans Live, 10 o'clock, and I'll see you there.